Hi guys, it's Boardmaths again, your favorite math tutor. So today I'll be talking about logarithm, how to simplify logarithm, how to evaluate logarithm, how to construct logarithm tables, and how to solve logarithm equation. Now let's start with the definition of logarithm. What is logarithm of a number? The logarithm of a number is that power to which the base must be raised to get that number. The logarithm of a number is that power to which the base must be raised to get that number. Look at this expression, log A base B. This is read as log A base B, and from the definition of logarithm, the logarithm of a number is the power to which the base must be raised to get that number. You can say let log A base B be x, and we have A is equal to B raised to power x. X is the power to which the base B must be raised to get the number A. And you should take note of something. If we are given the logarithm of number without the base, you should know they are all in base is 10. Now, the logarithm of 10 is 1, and the logarithm of 1 is 0. The logarithm of 10 is 1, and the logarithm of 1 is 0. That implies that number between 1 and 10 must have logarithm between 0 and 1. Now, how do we construct logarithm table? Let's start with that. We have some questions here. We have some questions, unsolved questions. Now, evaluate the following. Let's start with this. Evaluate 5.932 times 8.164 times 18.51. Evaluate the following. Evaluate 5.932 times 8.164 times 18.51. Now, how do we evaluate this? Constructing logarithm table depends on the law of indices. You need to apply the law of indices. You should recall from the law of indices. This is multiplication law of indices. A raised to power x times a raised to power y. This law states that they have the same base now, and they are multiplied together. Different power. We take one of the base and we add the powers. That's x plus y. So if the sign is not multiplication, what do we do? Well, we should take note. If the sign is multiplication, we are going to add the powers. A raised to power x divided by a raised to power y. That's a raised to power x minus y. A raised to power 0 is 1. Any number raised to power 0 is 1, except 0, which means 0 raised to power 0 is not 1, it is undefined. That's why you notice when you punch your calculator, 0 raised to power 0, you see mark error. That's undefined. Another one is nth root. A raised to power 1 over n is n root a. So constructing the logarithm table depends on the application of what? Of law of indices. And you should take note of this also. Under logarithm, we have what we call the characteristics, and we have what we call the mantissa. Let's say we have 1.5762. This 1.5762 is the same thing as 1 plus 0.5762. This is the characteristics. Sorry, this is the mantissa. This is the mantissa, and this is the characteristics. You have the characteristics. You have we have the mantissa. Okay, now how do we set logarithm tables? How do we set logarithm tables? We have number, we have log. Now, the first number that we have here is 5.932. We have 5.932. Now, let's take note of the characteristics, the mantissa. Now, what do we have here? 5 points. We have a number before the decimal points. A number, that's one number. Take this as 1. A number before the decimal points. So, the number is 1. We say 1 minus 1. That's 0. 0 points. Now, we check our logarithm table for the logarithm of 5932, which is given as the log of 59 under 3 difference 2. We have to look up for the logarithm of 59 under 3. Then the difference 2 we add to the results. So the logarithm of 59 under 3 difference 2. The logarithm of 59 is this. Under 3 is 7731. We have 7731. We have 7731. That's 59 under 3. 7731. The difference is what? 2. Difference 2 here is 1. So add 1 to this. That's 7732. Okay, that's the first one. Then the second number, don't forget, we have multiplication. They are multiplied together. So the second number is what? 8.164. Again, how many number before the decimal point? A number 1. 1 minus 1, 0. We have 0 points. We have to evaluate this without the use of calculator. That's why we are checking up our logarithm tables. Now, the log of 8.164 is given as log 81 under 6 difference what? Difference 4. So, the logarithm of 81 under 6, 81 under 6 is 9117. 9117 is 81 under 6. 9117. Then difference 4. The difference there is what? Is 4, which is 2. We add. That's 9119. Okay. The third number is 18.51. 18.51. Now, how many numbers? How many digits? Any number? How many figures before the decimal point? 2 before the decimal point. Then 2 minus 1. 1 point. Now, look up for the logarithm of 18 under 5 difference 1. The logarithm of 18 under 5, 18 under 5 here is 2672. 2672. That's 18 under 5. Then the difference is 1. Difference 1 here is 2 plus 2. That's 2674. Now, this is the result of this, and this is it. And they are multiplied together. And evaluating logarithm depends on application of law of indices. So multiply, we are going to add. So we have to add the results here. We have to add this together. So 0.7732 plus 0.9119 plus 1.2674. Okay, we can use our calculator to get the result of this, but don't use the calculator to find the logarithm of the numbers. You can just use the calculator to check if you are correct or not. So 2 plus 9, 11 plus 4, that's 15. But to save our time, we can just use our calculator since we have it here. 0.7732 plus 0.9119 plus 1.2674, which is 2.9525. Now, after getting the results of this, we need to check the antilog of the results, the antilogarithm, the reverse of this, the antilogarithm of this. Now, how do we check the antilog of this? We are looking for the antilog of numbers. We need to look for the antilog of the fractional part only. Now, what is the fractional part of 2.9525? The fractional part is this, 0.9525. Then the integer. This is integer. What is an integer? An integer is a number written without fraction. So the integer is what? Is 2. The integer is 2. Then we are going to use the integer to place the value of our result. So that means we need to look for the antilog of 0.95 under 2 difference 5. Now, this is still our logarithm table. We move to antilogarithm table. Points, as we can see, we have point. So 0.95 under 2 difference 5. 0.95 under 2 difference 5. 0.95 under 2 is 8954. 8954. So our difference is what? 2. 8954. Our difference is 2, which is 4. That's addition of 4. 8956. So we have 8956. 8956. And don't forget, I said earlier that we need to use the integer to place the value here. Now, the integer is what? Is 2. We take the 2. Instead of subtracting 1 from 2, we should add 1 with 2. 2 plus 1 is what? Is 3. So let's play that. 2 plus 1 is 3. We have 1, 2, 3. We have decimal here. So the result of 89, the result of this is 895.6. We have the logarithm to evaluate 5.932, the characteristics, the mantissa, a number before the decimal points. That's 1 minus 1, 0, 0 point this. 59 under 3 difference 2. Then 81 under 6 difference 4. Since we have the number, that's 0 point. Then 18.51. Two numbers before the decimal point. That's 2 minus 1. 1 point. Then the construction depends on the law of what? Indices. we add together and have this. Check for antilog. We check the antilog of the fractional part. Then we use the integer to place the value. That's 1, 2, 3. Then we can use our calculator to check if we have close value or not. 5.932 times 8.164 times 18.51 is 896.4. Yeah, which is very close. So another one, we have this. That evaluates 85.73 divided by 39.63. Evaluate that's evaluate 85.73 divided by 39.63. Now, how do you evaluate this now? 85.73 divided by 39.63. As usual, let's construct our logarithm table. 85.73. Let's check. How many numbers before the decimal point? There are 2 numbers before the decimal point. Okay? 2 minus 1. 1 point. Now check the logarithm of 85 under 7. Difference 3. Now the logarithm of 85 under 7 difference 3. 85 under 7 is 9330. 9330. Difference 3 is 2. 85 under 7 is 9330. The difference 3 is 2. That's 9332. 9332. So also we have 39.63. We have 39.63, and what is the logarithm of 39.63? That's 2 numbers before the decimal point. 1 point, because we have 2 numbers. 2 minus 1, that's 1. 1 point. Now 39 under 6 difference 3. Logarithm of 39 under 6 is 5977. 5977. 39 under 6. 5977. Difference 3 is 3. That's 5980. 5980. Now, construction of logarithm depends on application of what? Law of indices. So that implies we need to apply the law of indices. Division turns to what? Minus. We have to what? This is division. You have to subtract this from this. This minus this. This subtract this from this. So 1.9332 minus 1.5980 from our calculator. 1.9332 minus 1.5980. That's 0.3352. 0.3352. Now, the next step, check the antilog of the number. So how do you check the antilog of this? You check the antilog of the fractional part, which is the antilog of 0.33 under 5 difference 2. So we open to the antilog of 33.33 under 5. Difference 2. 0.33 under 5 is 2163. 2163. And the difference 2. 33 under 5. The difference is 2, which is 1. 2164. That's 2164. Then after that, you need to use the integer part to get the place value here. The integer part here is what? Is 0. Then we have 0 plus 1, which is 1. So we place 1 here. Because this is the integer part, which is 0. Then 0 plus 1 is what? Is 1. 1. So we tap on that. 85.73 divided by 89.63. 85.73. Two numbers before the decimal point. 2 minus 1, 1. The logarithm of 85 under 7 difference 3 is this. And 39 under 6 difference 3 is this. So we subtract. At the end of the day, we have 0.3352. Then the antelope, the reverse of logarithm of 0.33 under 5 times 2 is 2164. Then the integer here is what? 0. Use the integer to get the place value. 0 plus 1 is 1. 1. Okay? So let's move to the other question. Okay? We have this question number 3. Okay? Which looks more complex. The cube root of each bracket 39.32 times 2.964 all over 8.637 times 6.285 is power 2. Now, this looks complex, but okay, let's see, maybe we can evaluate this. Maybe we can decompose this complex value. Okay, 38.32 times 2.64 all over this square, cube root of the value. Okay, now I want you to remember the nth root here, nth root of indices. Nth root a raised to power 1 over n is what? N root a. So a raised to 1 over 3 is what? 3 cube root of what? Cube root of a. A raised to 1 over 3 is cube root of a. While a raised to 1 over 2 is what? Square root of a. Okay? So this can be written as this, can be written as 39.32 times 2.964 all over 8.637 times 6.285. Okay? We have square here. And remember that the cube root of a is the same thing as a raised to 1 over 3. So the cube root of this is the same thing as 1 over 3, which is the same thing as 39.32 times 2.964 all over 8.637 times 6.285. This is the logarithm when a number is raised to a certain power and the result is raised to another power. The power will multiply themselves. That's 2 times 1 over 3 is what? Is 2 all over 3. Then after that, we look for the logarithm of the numbers. Logarithm of the numbers. Okay, we have number log. First number here is, let's deal with the numerator 39.32. As usual, how many numbers before the decimal point? We have two numbers. That's 2 minus 1 is 1. That's 1 point. Then the logarithm of 39 under 3 equals 2. The logarithm of 39 under 3. The logarithm of 39 under 3 is 5944. Then difference 2 is 2. 5944 plus 2. 59446. Then we have 2.964 still at the numerator. 2.964. A number before the decimal point. 1 minus 1 is 0. Point. The logarithm of 29 under 6 difference 4. 29 under 6 is 4713. The difference 4 is 6. So 4713 plus 6 is 4719. So that's all for the numerator. Then for the numerator we see it is multiplied. A pair of indices we have to what? To add. So we have to add these values together. So let's add 1.5946 plus 0.5719, 2.0665. So that's for the numerator. Now, for the denominator now. Okay? There's no space here. Let me put it here. For the denominator, we have 8.637, which is a number before the decimal point. 1 minus 1 is 0. 0 points. Now the logarithm of 86 under 3 difference 7. Now the logarithm of 86 under 3 difference 7. Logarithm of 86 under 3. 86 under 3 is 9360. Difference 7 is 4. So that's 9364. So also we have 6.285 at the denominator. 6.285. So that's a number before the decimal point. 0 points. The logarithm of 62 under 8 equals 5. 62 under 8 is 7980. Difference 5 is what? 3. That's 7983. So also, they are multiplied together. We need to take the what? The addition. Don't forget we added the values here. So we need to take the addition of the numbers. So 0.9364 plus 0.7983. That's 1.7347. 1.7347. Now, that's the results are the what? Are the denominator. This we added, this we added. Now, as you can see, that means the result here is this. The result here is this. This is divided by this. Divided by this. So Law of indices, division, that should be what? Subtraction. We have 2 less. That will be 2.0665 minus 1.7347. That is the answer. 2.0665 minus 1.7347. That's 0.3318. This and this subtract. That's 0.3318. Now, that's the result. But it is raised power what? 2 all over 3. It is raised power 2 over 3. So if it is raised power 2 over 3, that implies that we need to multiply the result by 2 over 3. We need to multiply our results by 2 over 3. So 0.3318 times 2 is 0.6636. Then divided by 2, divided by 3 should be 0.2212. That's 0.2212. Then after, we need to reverse the logarithm. Look for the antilog of the numbers. But the fractional part, 0.22 under 1 difference 2. 0.22 under 1 difference 2. The antilog of 0.22 under 1 difference 2 is this. 0.22 under 1. 0.22 under 1 is 1663. 1663 and 0.22 under 1 is 163. Okay, then the difference 2 is what? Difference 2 is 1. That's 1664. So we have 1664 as the result. But here, the integer part is what? Is 0. That's 0 plus 1. 1. This value 1. So we have 39.32. The number before decimal point, 2 numbers, that's 1 point. Then this is 0 point. The result is this. You have to add the values. 8.637. That's 0.9364. Then 6.2885. That's 0.7983. The results you have to add together. After that, this is divided by this. This should be this minus this. 2.0065 minus 1.7347, which is 4.3318. But it gets power what? 2 all over 3. Here, then we multiply by 2 divided by 3. You have 0.221. Then the antidote of the value, you have 1.664 as the result. Okay. And let's talk about how to evaluate logarithm without the use of table. Given that log 2 base 10 is equal to 0.3010, log 3 base 10 is 0.4771. Log 5 base 10 is 0.6990. Evaluate without using table. Log 3.6 base 10. Log 50 base is 10. Now we have given as log 2 base 10 is 0.3010 and log 3 base 10 is 0.4771. Then log 5 base 10 is 0.6990. Evaluate log 3.6 base 10 and log 15 base 10. So how do we do this? We're given log 3.6 base 10 divided log 2 base 10, log 3 base 10, log 5 base 10. Now we need to check if the values here they are factor of this. But this 3.6 can be converted to fraction as 36/10. Then this is 36/10. 36/10 can then be written as log into base 10, 36 minus log 10 into base 10. So log into base 10, this 36 can be written as 2 raised to power 2 times 3 raised to power 2. Then minus log 10 is 1. So that's 2 log 2 base 10. Multiplication will turn to addition. Don't forget you are still using the law of indices. Then plus 2 log 3 base 10 minus 1. This power will multiply the logarithm. The power will multiply the logarithm. But you can just take it as log 2 raised to power 2 base 10 plus log 3 raised to power 2 base 10 minus 1. Okay, so how do we evaluate this now? Log 2 base 10 is what? 0.3010. Which is 2 log 0.3010 plus 2 log 0.4771 plus minus 1. So what's our answer now? 0.4771 2 times 0.3010 is 0.6020. Then 0.4771 is you have 2, 4, 5, 8.0 minus 1. So let's see. 0.6020 plus 0.8542 minus 1 is 0.4562. So 0.4562. But here, as you can see, let's take log 3.6. Log 3.6 is 0.5563. But here we have 0.4562. That means we need to look back again. Log 3.6 is the same as log 36/10. Because 36/10 is the same thing as log 3.6. Now, log 36 base 10 minus log 10 base 10. Log into base 10, 36 is the same thing as 9 times 4 is 36, which is 2 raised to power 2 times 3 raised to power 2. So if you have to apply the law of logarithm here, 2 log 2 base 10 is on to plus 2 log 3 base 10 minus log 10 base 10 is what? Is 1. So 2 divided 0.3010 is 0.6020 plus 2 times 0.4771 is this. That's 2 times 0.4771 is 0.9542, which is not 4. That's 9542 minus 1. So 0.6020 plus 0.9542 9542 minus 1 should be 0.5562. Because from our calculator, log 3.6 is this. So we're given log 3.6 without using table. Log 2 base 10 is 0.3010, and log 3 base 10 is 0.4771, and log 5 base 10 is 0.6990, which we don't need for. We don't need that to evaluate log 3.6. So 3.6 is the same thing as 36 over 10, which is log 36 base 10 minus log 10 base 10. 36, 2 and 3 are factors. 2 raised power 2 and 3 raised power 2. 2 raised power 2 times 3 raised power 2 minus 1. 2 log 2 base 10 plus 2 log 3 base 10 minus 1. 2 log 2 base 10 log 3 base 10 minus 1. Then the answer is 4.5562. Okay, so let's solve log 15 base 10 before we talk about logarithm equation. Log 15 base 10 is same thing as, you can see that 3 and 5 are factors of 15. That's log 3 times 5 base 10. Indices log 3 base 10 plus log 5 base 10, which is the same thing as 0.4771 plus 0.6990. Now from our calculator, 0.4771 plus 0.6990 is 1.1761. 1.1761. Okay, let's check log 15, which is the same thing as this. This is 1.1760 now. So we have 1.1761 as the results of that. Okay, welcome back. Now let's talk about the use of logarithm. The rules, or let's say the rules of logarithm. Because when we are giving questions on logarithm equations, we need to use the rules of logarithm to solve them. Now, the use of logarithm. We have the multiplication or the addition rule of logarithm. Now, what is the multiplication or addition rule of logarithm? Let's say we have log x base a plus log y base a. Now, this logarithm of numbers, they are added together. What can we see? We have the same base. Read as log x base a plus log y base a. You have the same base, right? But here we have x and y. They are added together. And from law of indices, when we have a raised power x times a raised power y, they are multiplied together. We need to add the powers. But here, they are added. We multiply the number. So we have log x y base a. Okay, let's say we have log 4 base 10 plus log 25 base 10. You see they have the same base. We take one of the base, then we multiply the logarithm itself. We have log 100 base what? Base 10. Another one, let's talk about the division or the subtraction rule of logarithm. The division of or subtraction rule of logarithm, we have addition here. The case when we have subtraction, let's say we have log x is a minus log y is a. Now the logarithm of number subtracted from one another, common base. Okay, we have log into base a x over y. Let's say we have log 4 base 2 minus log 2 base 2 of the same base. We take 1, 4 over 2, which is log 2 base 2. Okay. Now, let's talk about another one, which is what we call power law. This law states that when the logarithm of a number is raised to a certain power, the logarithm of a number is raised to a certain power, and the power must be used to multiply the logarithm itself. The power must be used to multiply the logarithm itself. The logarithm of a number, log x raised power y base a, is raised to a certain power. This logarithm of a number is raised to a certain power. The power should multiply the logarithm itself. The power must be used to multiply the logarithm itself. So we should have y log x base a. That's power law. Okay. Another one is, okay, let's say power base. Out of the case where it is the base that is raised to a certain power, not even the logarithm of the number in this case. Log x base a raised power y. This is log x base a raised power y. So when it is the base that is raised to a certain power, the reciprocal of the base will be used to multiply the logarithm itself. That will be 1 over y log x base a. Another one, we have the logarithm of a number to its own base. The logarithm of a number to its own base is 1. The logarithm of a number to its own base is 1. Log a base a is 1. Log 2 base 2 is what? Is 1. The logarithm of a number to its own base is 1. Another one is the logarithm of 1 to any base is 0. The logarithm of 1 to any base is 0. The logarithm of 1 to any base, let's say base a, is 0. The logarithm of 1 to any base is 0. So let's put that. The logarithm of 1 to any base is 0. Let log 1 base a be x. If log 1 base a is x, and remember that the logarithm of a number is that power to which the base must be raised to. That's a raised power x is 1, which is the same thing as a raised power x. The same. Let's take a as index of 1, a raised power 0. That's x is what? Is 0. That's 0. Then the last one, we call it the reciprocal law of logarithm. The reciprocal law. What does reciprocal law implies? Let's say we have log a base x. We want to change the position here. This is the logarithm a. This is the base x. We want to change the logarithm here, the position of the logarithm and that of the base. We take the reciprocal. That's log x is a. That's log x is a. So the rules of logarithm, we talk about the multiplication or addition rule of logarithm, the division or subtraction rule of logarithm, the logarithm of a number to its own base, the power rule, the power base, the reciprocal law, logarithm of 1 to any base, then the reciprocal law of logarithm. Let's take some sweet examples under logarithm. Then we apply the rules of logarithm. Okay? We still have our question here. Okay? We have, okay, find x. Find x if 6 log x plus 4 is equal to log 64. Find the value of x if 6 log x plus 4 is equal to log 64. Now, solve this now. We don't have any base here. Since the base is not given, we should know that logarithm, they are all in what? Base 10. So, we can have 6 log x plus 4 base 10 log 64 base 10. And remember power law of logarithm. When the logarithm of a number is raised to a certain power, the power will multiply the logarithm itself. Now, the power here has multiplied the logarithm itself. Let's reverse the law. Log x plus 4 is power 6 base 10 log. Then this 64 is the same thing as 2 to be multiplied by itself 6 times. 2 raised to power 6 base 10. Now, we see that the bases are equal. That's, there is equality. Then we should equate this and this. We have x plus 4 raised to power 6 is equal to 2 raised to power 6. Now look at something again. The power are equal. There is equality. We should equate this and this. We have x plus 4 is equal to 2. That's, okay, x plus 4 is equal to 2. That's 2 minus 4 is what? Minus 2. So, okay, we have x as minus 2 as our answer. Let's see. Let's check if we are wrong or we are right. 6 log x plus 4, that will be what? Minus x. That's x, then x is what? Minus 2. Minus 2 plus 4. 6 log, that's 2. Reverse, in base 10, reverse. 2 is power 6, which is 64. So, x is equal to minus 2 is the final answer to that. Okay, we have another question. Evaluate 5 raised to power minus 3 log 2 is 5 times 2 raised to power 2 log 3 is 2. Evaluate 5 raised to power minus 3 log 2 is 5 times 2 raised to power 2 log 3 base 2. Now, let's solve this one after the other. This and this. Okay? Let's 5 raised to power minus 3 log 2 base 5 be, let's take this as x. Okay? And let's take 2 raised to power 2 log 3 base 2. Let's take this as y. Okay. So that means this is x, this is y. Then our answer should be x times y, which is what we are looking for now. So 5 raised to power minus 3 log 2 base 5, which is equal to x. Now, how do we solve this now? Okay, we have 5 raised to power minus 3 log 2 base 5. Let's take, this is 5 raised to power this, and we remember that logarithm of a number to its own base is 1. So if we take the logarithm of both sides into this 5, then we can get rid of this 5, which we can get 1 at the end of the day. Log 5 is 1. So let's take the logarithm of the number into this 5. Then 5 raised to power minus 3 log 2 base 5. The same thing applicable to this, log of x into base 5. So we see that logarithm of a number to its own base is 1. So log x base 5. Okay, so of indices, when the logarithm of a number is raised to a certain power, the power will multiply the logarithm itself. This is the power. Minus 3 log 2 base 5 log 5 base 5 is equal to log x base 5. Then this is what? This gives 1. At the end of the day, 1. Log 5 base 5 is 1. This is 1. So 1 times this is minus 3 log 2 base 5 is equal to log x base 5, which is the same thing as the logarithm of a number also is raised to a certain power, the power should multiply the logarithm itself. So let's reverse. That will be log into base 5. Then we have 2 raised to power what? Minus 3. We reverse the power law, because this minus 3 will obey the law of logarithm and multiply here. So we have log x base 5. And also, they have the same base here. There is equality. So we should equate this. They have the same base. So we should equate this and this. So that implies that 2 raised by minus 3 is x. So 2 raised by minus 3 is the same thing as 1 over 2 raised by 3. So which is the same thing as x. So 2 raised by 3 is 8. Then x is equal to 1 over 8. X is equal to 1 over 8. Then for this y now, for y, okay, we have 2 here. That means we need to take the logarithm of both sides into base 2. Because of this 2 here. Because there is 5 here, we take logarithm of both sides into base 5. Here, the 2 here, logarithm of both sides into base 2. 2 log 3 base 2 is equal to log y base 2. Now the logarithm of the number, that's 2 log 3 base 2 log 2 base 2 log y base 2. So logarithm of the number to its own base is 1. So log 2 base 2 is 1. So that's 1. If that is 1, then we have 2 log 3 base 2 as log y base 2. Let's reverse the power law. Log into base 2, 3 raised by 2 base 2. That's log y base 2. They have the same base. There is equality. Equate the logarithm of the numbers. So 3 raised by 2 is equal to y. Implies y is equal to what? 9. And let's go back to this box. Unknown. X is what? Is 1 over 8. Then our y is what? 9. So the answer is 9 over 8, or 1 whole number 1 over 8. So we're giving the recap on that. Let's do recap on that. We're giving evaluate 5 raised by minus 3 log 2 base 5 times 2 raised by 2 log 3 base 2. Then we remember from law of logarithm that the logarithm of the number to its own base is 1. Then we have 5. Then if we take the logarithm of both sides to base 5, then we can say log 5 base 5 is 1. Then from the logarithm of the number raised to a certain power, the power will multiply the logarithm itself. Log 5 base 5 is 1, out. Log s is 5. 2 raised by minus 3. Reverse the power law of logarithm, and log s is 5. So 2 raised by minus 3 is what? 1 over 8. And we have log x is 5. There is equality because they have the same base. So 2 raised by minus 3 is equal to x, because we equate the logarithm. We neglect this. Then 1 over 2 raised by 3 is what? 1 over 8. X is 8. The same thing applicable to this. This is 2. We have log 2 raised by 2 log 3 base 2 log y base 2, then we have this. At the end of the day, log 2 base 2 is 1, then there is equality, they have the same base. 3 raised power 2 is 9. If y is equal to 9, let's go back to this box. X times y. Our x is 1 over 8, and our y is what? It's 9, which is 9 over 8. Then, at the end of the day, convert to this fraction, because this is an improper fraction. And our answer is 1 whole number, 1 over 8, which is the final answer. Okay, so let's give out some exercises. So I'll be giving out some exercises now, which I would love you guys if you can answer the question and put it on the comment section. The answer to this and put on the comment section. Log x base 5 is equal to 8 log 5 base x plus 2. Find x. Log 5x plus 6 plus log 3x plus 2 is equal to log 15x squared plus 12x plus 60. And log 4 base 2 plus log 7 base 2 minus log n base 2 is equal to 1. Find x if. So how about if you guys solve these questions and you put it on the comment section. So thank you for staying with us for this long class. Please share my videos and please subscribe to my channel, because your support has been a source of encouragement that propels the channel forward. And if you need any help on mathematics, any subject, any science-based subject, commercial-based subject, art-based subject, you can please reach us. Thank you for listening.